So I'm going to talk about slides 38 through 44 within chapter 7. So the topics within these slides are the structure of an SQL query, and then the operations of select distinct, select all, between blank and blank, as well as not between blank and blank, and then like, as well as not like. So starting with the structure of an SQL query, from earlier slides, we saw that the select clause can be represented by the pi symbol or projection. The from can be the Cartesian product or the cross, and the where clause can be the selection or sigma. So if we take a look at this SQL statement here, select distinct ri.a, rj.b, so on to rk.c, from R1, R2, so on to Rn, where whatever conditions apply. So for now, we can just not worry about the distinct because we will address that in a later slide. But that statement there can be rewritten and is actually equivalent to pi of ri.a, rj.b, so on to rk.c. And then within the parentheses, we have sigma of our conditions. And then in another set of parentheses, we have our where we're pulling from the table name. So R1 cross R2 cross so on to cross Rn. So those two statements are actually equivalent to each other. They're just different ways to write it, different representations. So from here on out, we're going to be talking about different operations. And as an example, I'm going to be working off of this table here. So I have the SQL statement where I created my table. It is called students. It has a total of 4 different attributes to it: an SID, which is the primary key, a name, a major, and a GPA. So that's what each of these students has. And if we take a look down at the table, we can take a look at an example as Emma, who's the first one. SID is B001. Name is Emma. Her major is anthropology. And her GPA is 4. So her GPA is 4.0, but just the way that things are outputted and printed, it does not include the decimal. So that is 4.0. And then if you look further down, Becca also has a GPA of 4, which is actually a 4.0. So our first operation here will be select distinct, which when you use this, it returns all the rows without any duplicates involved. So just for reference, our original table is up here in the top right-hand corner. And then to use this statement, we just select and add that distinct keyword. This time I'm choosing to pick majors. So I do select distinct major from my table students, and it outputs all of the majors. It has anthropology, computer science, linguistics, history, and interior design. So if we look back at our original table, remember to it, we'll remember that 3 people had the major of computer science. But in this output here, it only lists computer science once. So what distinct does is it takes every possible option and just gets rid of the duplicates. It just gives you one of each and every unique possible attribute. In this case, every unique major. So it only appears once. So something to remember with select distinct is that it may not be very efficient at times. Because if we take a look here on our left-hand side, I'm using select distinct with the SID in the major this time from our same table of students. And this time I get all 3 computer science to show up. This is because the SIDs are different. So because I'm taking both of them, they're considered unique. And I get the exact same result in this right-hand box by just doing the normal select SID major from students without the distinct keyword. As you can see, they're the same with all 3 computer science showing up. So the next operation we have is select all. This returns all the rows, but this time it keeps the duplicates, and the all keyword is an explicit I want duplicates. It makes sure that the duplicates stay. So we have select all major from students. And as you can see, computer science appears 3 times, which is actually the same as just doing select without the all keyword, but you can use the all keyword if you want to be absolutely sure you get the duplicates. So the next one that we have is between. So this one returns rows that have a condition that fall within, in this case, a specific range of numbers. So I have here select, I want the name and the GPA from my students table. In this case, I'm saying where the GPA is between 3.0 and 3.9. So in this case, there are 4 students that have that, Nick, David, Avi, and Need. All have GPAs between 3.0 and 3.9. And if we look back up at our original, Emma, Becca, and Kat all do not have GPAs within that range, so they're not included in here. Then if we go on to the next one, it's very similar, it's just the opposite. It's not between blank and blank. So it returns the rows that have the condition that is not within the range given. So if I'd use the exact same command, select name and GPA from students where GPA this time is not between 3.0 and 3.9, instead of getting Nick, David, Avi, and Need, this time I get Emma, Becca, and Kat because their GPA does not fall within that range. As you can see, Emma and Becca have 4.0 and Kat has a 2.8. So that is why they appear in this one. So our next operation is like with the percent symbols. So what this does is it matches 0 or more characters that you can put between the between the percents, sorry about that, and it returns the rows that have that as a match. So on the left-hand side here, we have select name and GPA, so same as the previous slides, from students where the GPA is like, and then you do single quote, percent, I chose to do 3 point, percent, single quote. So this looks through our GPAs here and finds all of them that have somewhere in it, it could be anywhere, a 3 dots. In this case, that happens to be 3.6, 3.3, 3.3, and 3.8. So it gives me Nick, David, Avi, and Need again in this case. And then on the right-hand side here, it is very similar. It's just the opposite of that. So it's not like percent blank percent. And it matches 0 more characters and returns the rows that do not match that. So using the same command, it's select name GPA from students, where the GPA is not like single quote, percent, 3 point, percent, single quote. So I get Emma, Becca, and Kat this time because they do not have the 3 dot anywhere within their GPA. So, and then the final operation that we have here is another like. It's the same keywords, it's just used a little bit differently. So this time it matches the number of characters equal to the number of underscores and returns those rows. So if I take this one here, which is my title of the left-hand side, I have 3 underscores. So it would look for anything that is 3 characters in length and return that. So the underscore can match to any character that is present. It does not matter what it is. However, you can put a specific character in one of those spots instead of the underscore to specifically look for a certain character. So on my left-hand side screenshot here, I did select name from students where name, like, single quote, the letter capital N, and then it's hard to see based on the formatting of the terminal there, but it is 3 underscores. I have this right down here written out so with spaces in there so you can see that a bit better. So what this is doing, it is looking for any name in the students table where the name starts with an N and is 4 characters long. So we get Nick and Need as the result of that. Now, if you note, there is another 4-letter name or a 4-character name, which is Emma. But because Emma does not start with the letter N, it does not get returned in this case. And then on the right-hand side, very similar to the other ones, this one's just not like. So it finds whatever matches and returns everything else. Same things apply to this. The underscore can go to any character, but you can put a specific character if you'd like. So for this example, I did select name from students where the name is not like, and then I did 3 underscores here. Again, the command with spaces is down below the screenshot. So what this is saying is find every single name and return it that is not 3 characters in length. If it's 3 characters, do not return it. If it's anything, if it's more or less, return that to me. So we got Emma, Nick, David, Becca, and Need. All of those happen to be 4 or 5 characters. And if we look at our original, we see that Avi and Kat are not present because their names are 3 characters in length. So they meet the criteria to not show up here. And that is all. Thank you very much.